Turn off the lights. Now look into the darkness. You know you're probably safe. You know this is the same room you've seen hundreds of times. And yet, the moment the light disappears, something changes. Your attention becomes sharper. A small sound suddenly seems important. A shadow seems different. And the darkness can suddenly feel unfamiliar. But why? Are humans actually afraid of the dark? Or is something else happening inside the brain? Scientists have studied this question in controlled experiments. And one of the most interesting findings is surprisingly simple. Darkness can change how humans react to sudden sounds. In laboratory experiments, people showed a stronger startle response in darkness than in light. This reaction is called the acoustic startle response. It is a rapid defensive reaction to something unexpected. A sudden noise can make your muscles tense. Your attention shifts. Your body prepares to react. And this can happen before you consciously understand what caused the sound. Researchers found that darkness can increase the magnitude of this response. The effect is measurable. But this creates another question. Why should the absence of light change the way your nervous system reacts? One important clue is information. When there is enough light, your eyes constantly provide information to your brain. You can see the walls, the furniture, the doorway, movement, objects around you. You can understand your surroundings. But when the lights go out, much of that information disappears. The room itself has not changed. Your access to information about the room has. And that difference matters. Because the brain is constantly trying to understand what is happening around you. Is that sound important? Is that movement dangerous? Is that object familiar? Imagine hearing a noise behind you. You cannot see where it came from. Maybe it was the building. Maybe something fell. Maybe it was an animal outside. Maybe it was nothing. There are several possible explanations. But you don't immediately know which one is correct. That uncertainty is important. Research on anxiety shows that uncertainty about a possible future threat can influence attention and emotional responses. There does not have to be an actual danger in front of you. The possibility of danger can be enough to change how you respond. Think about walking through your home at night. During the day, you barely notice the hallway. At night, the same hallway can feel completely different. You may walk more carefully. You may listen more closely. You may look toward shadows. Nothing necessarily changed. Your perception did. This does not mean your brain has become irrational. It means your nervous system is dealing with incomplete information. When you cannot confidently determine what is happening, paying closer attention can help you gather more information. But this system can also produce false alarms. A sound can turn out to be harmless. A shadow can turn out to be a coat. A movement can turn out to be a curtain. And a possible threat can turn out to be nothing at all. The initial reaction can still be real, even when the danger is not. You may have heard that the amygdala is the brain's fear center. But modern neuroscience gives us a more complicated picture. The amygdala is important for processing threats and emotional information. But fear and anxiety involve networks of different brain regions working together. These networks include regions involved in threat detection, attention, learning, and emotional regulation. Different systems contribute to different parts of the experience. Detecting a possible threat, learning whether something is dangerous, maintaining attention, and preparing the body to respond. So fear is not simply one button inside the brain. It is a coordinated process. And darkness can create an environment where these systems become especially relevant. You have less visual information. Sounds can be harder to identify. Objects become ambiguous. There is another strange thing the brain does. It looks for patterns. Humans are extremely good at recognizing meaningful shapes, especially faces. And sometimes, we find faces where there are none. This phenomenon is called pareidolia. You might see a face in a cloud, in a building, in a shadow, or in an ordinary object sitting in a dark room. Imagine a coat hanging on a chair at night. In daylight, you instantly recognize it. In darkness, its outline can look completely different. Two shapes might look like shoulders. Another shape might look like a head. For a moment, your brain can interpret the object as something else. Then the light comes on, and you realize what it actually is. The coat never changed. Your visual information did. This is not necessarily a hallucination. Your brain is receiving real visual information. The problem is that the information is incomplete or ambiguous. Research shows that face-like objects can activate parts of the brain involved in face perception. The brain can begin processing something as face-like, even when it is not actually a face. And this process can happen surprisingly quickly. The human visual system is highly sensitive to face-like patterns. Faces carry enormous amounts of information. Who is looking at you? Are they familiar? Where are they looking? The brain is extremely interested in these questions, but darkness weakens the information needed to answer them. You may see only a silhouette, a shape, a movement, a small amount of contrast, and your brain has to interpret it. Sometimes the interpretation is correct. Sometimes it is not. You see a person, but it is only a coat. You hear footsteps, but it is only a sound from the building. You see movement, but it was only a shadow. Darkness does not have to create something frightening. It only has to make ordinary information harder to interpret. Now imagine you're alone in a dark hallway. You hear something. You stop. The sound disappears. You wait. Nothing happens. But you are still listening. Your attention remains focused on the possibility that the sound could happen again. This is threat anticipation. Your brain is not necessarily saying that something dangerous is definitely there. It is preparing for the possibility that something might happen. And this distinction is important. Fear is not always about certainty. Sometimes it is about uncertainty. If you know exactly what is happening, you can respond. If you know that a noise came from your refrigerator, there is no mystery. But if you cannot identify the source, your brain has a problem. It needs more information. So you listen, you look, you wait. This may help explain why darkness can make familiar environments feel unfamiliar. Your bedroom is the same bedroom. The hallway is the same hallway. The furniture has not moved, but your visual system is receiving less information. And perception is not simply a recording of the world. Your brain is constantly interpreting sensory information. Change the information, and the experience can change with it. This is why the same room can feel completely different during the day and at night. During the day, objects are easy to identify. At night, they become silhouettes. But we should not make the mistake of saying that everyone experiences darkness in exactly the same way. People differ. Some people barely notice it. Others feel uncomfortable. And for some people, fear of darkness can become severe enough to qualify as a specific phobia. There is no single explanation for everyone. Our reactions can be influenced by experience, learning, context, expectation, and individual differences. This is why one person can walk through a dark house without thinking about it, while another becomes extremely alert. The darkness is the same. The human response is not. Research has also found relationships between fear of darkness and measurable defensive responses. But these relationships do not mean that one simple factor explains everything. Human behavior is rarely that simple. Fear is influenced by many interacting systems, and darkness is only one part of the picture. So what about evolution? You will often hear a simple explanation. Humans evolved to fear darkness because predators hunted our ancestors at night. It sounds convincing, but science requires more caution. The evolutionary explanation is plausible, but it is not proven as the single cause. Reduced visibility could certainly have made it harder to detect potential threats. But we cannot honestly say that scientists have proven that ancient predators created our fear of darkness. The evidence is more complicated. Some explanations are supported by research, others remain hypotheses, and separating the two is important. What we can say is that humans evolved with nervous systems capable of detecting and responding to potential threats. Those systems are still active today. Modern life has changed dramatically, but the biological machinery involved in threat processing remains part of the human nervous system. Today we have electric lights, street lights, phones, cameras, security systems. But our nervous system still has to interpret uncertainty. Technology can change the environment. It does not instantly change the basic biology of perception and threat processing. When the lights disappear, your brain still has to work with whatever information remains. You cannot see as much. You cannot identify as much. You cannot predict as confidently. And that can change how your brain evaluates what might happen next. Think about a dark room again. There is no monster, no intruder, no supernatural creature, just a room. But you hear a sound. You turn your head. You cannot see its source. For a moment, uncertainty increases. Your attention shifts. Your body becomes slightly more prepared. Then you discover the truth. It was nothing dangerous. The alarm disappears. This is what a false alarm can look like. Your defensive system reacted to a possibility. Then new information arrived.